Okay, this lecture is going to be about Ernest Rutherford and his gold foil experiment. This one's really important, so make sure you got great notes for this one. Our aim is to see how this model diverges from the last model we studied, which was plum pudding. So take a moment after I read these questions and pause the video and get yourself primed for the lesson by thinking of answers to this do now question. So, firstly, which of the four Greek elements are actually elements according to our modern definition? What do air, earth, and water have in common? What do fire, sound, light, and electricity have in common? And what was the most important revision to the atomic model by Thomson? So, Rutherford was the next scientist to contribute greatly to our understanding of the atomic model. Some key players in his experiment were alpha particles, which we think of as helium atoms, that are moving at very high speed and they're ejected from the nucleus of an atom. And the atoms he was looking at in particular were gold atoms. So some of the background is that he used alpha particles, which were being ejected from these radioactive materials like uranium, and they were shooting out these positively charged alpha particles. He used those to investigate the composition of gold. So this is the basic setup of his original experiment. You have a fluorescent screen which surrounds a gold foil. Oh, and by the way, guys, we're looking down on this, so this is a top view. So we have a gold foil, which is made of gold. It's 1 atom thick. He has a uranium source, which is going to eject alpha particles right out there. And he has a lead block encasing that just to give himself some protection. So one thing that you definitely need to know is that you'll know that the alphas are striking the screen because the fluorescent screen will light up. Using our knowledge of the atom, where do you predict the alphas will strike the screen? Take a moment, pause the video, and make a prediction of when these alphas are shot out and they hit the foil. Where do you think that they'll actually hit the screen after hitting the foil? So, I think this is what Rutherford predicted would happen. He thought that the atoms were actually different than Thomson's plum pudding atoms. He thought that these atoms were probably really just very empty. And he thought that since they were empty, that the alpha particles would go straight through the gold foil. But the results he actually got were more like this, in that some of the particles behaved as he predicted. Some of them did go straight through the gold foil and struck the screen back here. But many of the particles were deflected, both at small angles but also at large angles, after striking the gold foil. Basically, what we think has happened is that alpha particles were moving around in space, and they sometimes would encounter gold nuclei, and sometimes they wouldn't. So these red circles with positive symbols, those are my symbol for the gold nucleus right now, and these, of course, are my alpha particles. This isn't a nice sketch to have in your notes, but when you're watching this, it's gonna be animated, so when you make a sketch, use your imagination to make a sketch that makes sense for what you've seen. Alright, so basically, the particles are going to be flying in from the left, and you will see that some of them will strike the foil. Like, for instance, this guy right here is going to strike a gold atom. But this one isn't. It's not going to strike a gold nucleus as it flies through. And then others, like this one, won't strike a gold nucleus, but they'll come really close. And all of these things will have different effects. So as I let the animation play through, you see that this one right here did, in fact, strike the foil and is bouncing backwards right now. This one is just sailing through. And this one is right here is about to interact with the nucleus, even though it's not going to strike. So I don't know if you see it, but this guy right there has changed direction. And that's because the alpha particle itself is positive, and the nucleus is also positive. So if this is positive and that's positive, then this guy is going to fly away after being repelled by the nucleus. We've really reached the end of the lecture part of this lesson, but what I want you to do right now is go to the classwork section of your binder and write down the questions in this pair up. We'll use it in class tomorrow, and so write down these questions. You don't need to answer them. We'll use them in class tomorrow. I'll also answer this summary question tomorrow, so be prepared for that.